Hi, this is Alex from devstories.eu. PyTorch Fundamentals, Episode 6 of 18. Your model is only as good as the data you feed it. But what do you do when your dataset is a terabyte in size and your machine only has 16 gigabytes of RAM? The answer lies in how you fetch that data. This episode covers datasets and data handling. Data processing logic can quickly get messy. If you mix your file reading, decoding, and formatting code directly into your training loop, your project becomes brittle and difficult to maintain. PyTorch encourages you to decouple these concerns. You want your data preparation completely separate from your training algorithm. To achieve this, PyTorch provides a primitive called Dataset, located in the torch.utils.data module. The Dataset class acts as a standardized wrapper around your raw data. To handle your own specific files, you create a custom class that inherits from this primitive. When building a custom dataset, you must implement three specific methods. These are init, len, and getItem. The init method runs exactly once when you create the dataset object. This is where you configure your directories and paths. A frequent mistake beginners make is trying to load all the actual data into memory right here. Do not do this. If you have 50,000 high-resolution images, reading them all into memory during initialization will immediately crash your machine. Instead, use init to load a lightweight index. For example, you might read a CSV file that contains image file names in one column and their corresponding text labels in another. You are just building the map, not holding the territory. Next is the len method. This simply returns the total number of samples in your dataset. If your CSV file has 50,000 rows, this method returns the number 50,000. The system relies on this to know the absolute boundaries of your available data, so it does not request an index that does not exist. The heavy lifting happens in the getItem method. This function is designed to load and return a single sample at a specific requested index. When the system needs sample number 42, it calls getItem and passes in that number. Your code looks up row 42 in the CSV you loaded earlier. It reads the file path string from that row. Then, and only then, it accesses the disk, finds the file, and decodes the actual image pixels into memory. It grabs the label from that same CSV row and returns the image and the label together as a tuple. This technique is called lazy loading. You only consume memory for the specific piece of data you need at the exact moment you are ready to process it. By isolating this logic inside the getItem method, your training code never needs to know if the data came from a local hard drive, a network stream, or a complex database. It just requests an index and receives a standardized output. Separating the mechanism of how data is fetched from how it is consumed is the foundation of scalable machine learning code. If you find these episodes helpful and want to support the show, you can search for DevStories EU on Patreon. That's all for this one. Thanks for listening and keep building.